Secretariat will take some support from NSGM or some other agency, so that there is, because it will be a big task to take care. So and NSGM will be a, I think, good. So we'll discuss.
Yes.
We'll take it forward. I think it's a good suggestion. Thank you.
Thank you, sir.
Yeah.
So going forward in this direction, we have Anoop Kaur Bowdery, CEO EDX Wireless. Mrs. Yeah, please. Yeah. So you would like to make a presentation?
Yes, I've got a presentation.
Okay, fine. So if you could quickly give your intervention on that. Yeah.
Sure. Maybe they've lost my presentation. Is it coming? Yeah, this morning. Yeah. Sure. While they get the presentation, I'll introduce myself. So Anoop Bowdery, CEO of EDX Wireless. So today I want to talk about the challenges of smart metering and maintenance. There was a lot of questions on the panel when it came to digitalization, so I chose the one that's more pertinent to India at this time, which is deploying mass amount of meters and the challenges one sees with them. So when you think of smart meters, on paper it's pretty simple. You deploy, connect, and collect. But in actuality, that is not the case. Once you have an ecosystem there are a lot of things you have to take into account. Smart meters are on the intersection of hardware, connectivity, data, people and policies, which we all brought up about. People and policies, we've seen globally have been a problem. So the other thing to bring there is, along with these four challenges, the major challenges we see are connectivity. If your mass meters are not deployed, and they're not deployed with the proper techniques, you're going to lose money. You're going to lose on manpower. You're going to lose out on all the CapEx and OpEx you provide and put in. This is where I need my slides. Oh, okay. And so we saw from global operators and utilities the problems they had, and I think India is at a great position to learn from all the mistakes, challenges and hurdles we've seen in the US, Australia, when it came to mass deployments. So for connectivity, when we look at connectivity, not one model fits all. Why? Because we have diversity. If you look at India, every state has a very different, diverse environment. You have buildings, you have terrain, you have rural areas, suburban areas. You put down your meters, and to connect back, it's not always going to work. Why? You have an RF signal. We're going into a technology where RF signal makes a big difference. You can put in a plug and play, but there's interference. You have operators with their frequencies you want to use. So it's very important that we have good propagation modeling. We saw in the US folks like PG&E who went out and deployed en masse in California. They didn't do any kind of modeling. They pushed out all the equipment, all the meters, and they had problems with connectivity because California, like some states in India, has mountains, has a beach, has very different environments. And what happened? They had to stop, restart again. But the other important thing to consider is people and policies. People, as in the consumers, like you've all mentioned already, were not accepting of new technology. They were not accepting of these new smart meters put in. They didn't trust the technology. They didn't trust they're going to be built the correct way. And they were very scared of RF signals and how it affects them. And that caused a massive problem in their deployment. They had to halt because people were like, no, we don't want this. So what they had to do is a consumer education. The government put together consumer education where they educated everybody on why this was a good idea, why it didn't affect their health and how it didn't overcharge them. Because the other problem that happened is when you have mass deployment, you also need a big IT infrastructure because you're going to have real-time data, and that data is going to come in mass. If your backbone is not ready for that, you're going to fail. So putting that in place and charging the consumer correctly. Any mistakes and you overcharge them or you don't charge them, you're causing a mistrust with the public, and that is a problem. The other issue found and is needed is the buy-in from the government and from the regulators. They need to put into place standardizations. That way everyone follows the same standardization and you can deploy in a very smooth process. You avoid a lot of the problems and pitfalls you see. And I think learning from what's happened already and bringing it to India would be, I think, the best way forward to understand what happened and what they did. That way you can accelerate your deployment faster. And then moving on, once you're deployed, you have a massive data, and that's when bringing in data helps. That's pointless now. All right, so this is what I'm speaking about, the major challenges. Scale meets variability. India is beautiful. India has a very different terrain everywhere you go. So you have to ensure that you have coverage. The problem isn't meters. Your hardware is there. The problem is connecting the meters back into your gateways and stations and having that connection. If you have mass deployment and your manpower doesn't deploy them correctly, you have a problem. Connectivity is often the weakest link. We're introducing now into utility space RF. It wasn't there before as such, and now it is. So now we have to deal with the sensitivity of RF. Integration complexity, sorry. This is another hurdle, and we see this in the US as well, where you have a number of vendors, technologies, all working together to be able to provide the DISCOMs information about their users, about predictive maintenance, and about all the issues you're going to see in the network and capacity planning as well. People and policy, huge. If this is not taken care of, it's going to cause even more delays than you already see. So one use case here from scale meets variability is from Canada, from Hydro One. Again, challenge, enormous area. They went out and installed meters everywhere and then found they didn't connect. Why? Because the RF conditions weren't correct and they didn't deploy properly. They needed to be able to do RF modeling. Connectivity and examples. So I brought some examples. I think it speaks volumes where people have done something and the lessons they learned, which we can leapfrog from, is Centerpoint in Texas. They have a very strong AMI mesh network, but they suffer from natural disasters, and they found they had packet losses and latencies issues. What did they do? They introduced a redundant backhaul link. Redundancy is very important. If you have one connection out, your grid goes down, you're going to lose connectivity. Redundancy is very important. So when you are planning, it's also important to plan how you connect back with natural disasters, because they happen. Integration complexity. So here's a use case from Ausgrid in Australia. So they had AMI data flow into separate systems. And so we have customer engagement, you got your CRM, your trouble ticketing, you had your demand management. And then the mismatch of readings, the problematic issues with tickets cause a lot of confusion and mistrust. So it is very important to have an enterprise layer to collect that data and to be able to report back seamlessly. Otherwise, you have serious problems. And that is true digitalization, is interoperability. People and policies, so I mentioned PG&E, a very famous use case where they had to stop and go in phases, buy in public and government standardizations for it to work. So the operational benefits to DISCOMs is efficiency. Efficiency is key. If you're not efficient, you're going to lose money with manpower, fixes, troubleshooting. They found with accurate and automated billing, which is where you want to get to with all that data you have, they saw a 20 to 30% improvement, which is a nice large number there. A loss reduction, real-time collection and visibility into technical and commercial losses, which is exactly when you want to get to when you have real-time data. Operational insight, you're able to make better decisions once you have that data. And then planning and forecasting, which is where you want to get to be able to address real tariffs, address your predictive maintenance, and then say, okay, well now my grid is working, I can now put efficiency in there and put solar in there, green in there. How do I make it sustainable? And then a use case there from DISCOM digitalization is from Florida, Power and Light, where they have automation and now they can be more proactive to issues found. So they connected over 5 million smart meters with sensors and outage management. And Florida is always sensitive to a number of natural disasters. So when they have their disasters, they found a reduction in outage, which is exactly what you want. You have an outage, your system goes down, your consumers are not using. You want them to be using, and emergency services to be able to use. Oh, my time's up. I'm just finishing off now.
May
And that
I
brings
ask
us
you to
close to the
conclude?
end, the last slide.
Sorry?
I'm at my last slide now.
Okay.
Yeah, sorry. And then key takeaway, we're also doing AMI 2.0, where we're looking at more of the grid modernization and being able to be sustainable, introducing new technologies. And at EDX, come see us at a booth. We are doing a lot of work with global utilities in grid digitalization. Thank you.
Thank you, ma'am. So very appropriately put that, communication is going